Welcome to Unit 1, Module 2, Lesson 3. Today we're going to talk about functions. So, what is a function? A function changes data or completes a task. It's a single encapsulated task. That means everything that's done within that group, and then the function just disappears from memory. So, EarSketch has a couple built-in functions. We've already discussed them. We have the init, which is the initialization function. We have the set tempo function, which sets the tempo of our song. We have the fit media function, which actually does the work of writing our music. And then we have the finish function, which closes everything down. The values in the parentheses, these are called the arguments of the function. They get sent to the function definition written somewhere in code, which we'll talk about later, and the work is done by the function, and then information is set back in a return value. So some value is sent back in most cases, but not in all cases. So none of these actually send a value back. This kind of does. It sends a value back on the screen. You can see when you run it, but these three really don't send any back. We're going to look at some other functions that actually return some information, and we can see some of these outputs in the console window. So let's get started and take a look at some of the other built-in functions that are part of Python, not just part of EarSketch. First, we have the round function, and this will take a decimal, so either a float or a double type, and it will round the value mathematically according to the number that's here. So if we put in 15.56 comma 1, it will give us an answer of 15.6, which is rounding to one decimal. 0 decimal is an integer number, so if we just wanted to get a 15, we would just put comma 0 and would give us a 16 actually as an answer. So let's give that a try in EarSketch. So I'm in my EarSketch sandbox here that I've created for myself. And I have a print command because round is actually going to return a value, and I have to do something with that to catch it. And I can either store it in a variable or I could print it. I'm going to choose to print it this time. And I'm going to round this number here to the third decimal. So I'm going to come over here and press run. And down here in my console, I can see that I got 3 decimal places, and it is correctly rounded. It took the 5 and turned it into a 6. Let's take a look at some more functions. The next function I'd like to talk about is ABS. That means absolute value. So if we go into EarSketch again, I can print out the absolute value of negative 23. So I have typed in here print ABS, put in my argument of negative 23. I'm going to press run. And I can see that down here in the console, I do get 23 as expected. Just for fun, let's try this. Suppose I assign my ABS, create a variable, and I say ABS negative 45, or how about just 45, just to prove that that works. And we're going to print out my ABS. So when we run this, we are actually catching the value from the absolute value and storing it inside of my ABS, and then we're printing it out, and we get the results that we expected. The absolute value of 45 is 45. Let's take a look at another function. So the hex function is kind of an interesting one. I talked about how hexadecimal is used in other computer languages. Actually, it was used originally in most computer languages until Grace Hopper came along and ended up giving us a computer language called COBOL, which allowed us to write commands and use words, which makes life so much easier. But we used to write everything in hexadecimal. So hexadecimal is based upon a base 16 number system. We have a base 10 number system. And sometimes we need to convert back and forth. We'll talk more about why we would need to convert that, because sometimes we just need to know what the computer would understand. Hex 300. So if we took our number 300 and converted it, it would actually convert to a pretty weird number. We would get this as a response, 0, and then this X symbol, and then 12C. What that's saying is, this symbol here lets us know that we are in hexadecimal, and it's going to tell us the number is 12C. What the heck does that mean? Well, it means that C represents the number, let's see, A is 10, B is 11, 12 is 6. So if we take 12 times 16 and then add that to 2 times 16 squared and so forth, so we can calculate how that works up and adds all the way up to 300 by using the place values here inside of our hexadecimal. So that's really how that all works out in hexadecimal code. We're not worried about writing in hexadecimal, but I just wanted to show you another function. And this is the command that would print that out. Now, a very useful function is the POW function. That is the power function. The first argument in the power function is the base. The second argument is the exponent. So let's give this a try. So I have 3 examples here. My POW function does return a value, so I do have to catch it with a print statement or store it in a variable. The first one has an argument of 5, 3, which will be 5 to the third. The second one has an argument of 5, -3, which will be 5 to the -3rd, which will produce a fraction for us. And the last one will be 5, 1 divided by 3, which would give us a radical function, a cube root specifically. So let's hit run and see what we get. And we can see that we get the 125, we get 0.008, and then down here we get 1. So something weird happened. This didn't quite exactly work the way we had wanted to. The cube root of 5 isn't 1. So we might have to do something here. Instead of doing 1/3, let's do 0.3333, see if that works better. Oh, look at that. Now we got it. So we can't use our fractions there. We have to use our decimal there as our second argument. And we ended up getting the cube root. It's a little weird because we should be doing 0.333 repeating, and it seems okay with 0.333. So this is a little bit odd. We're going to have to take a further look at this later on when we talk about the math functions. But this is how you would use POW. So the next function I want to look at is the sum function. This works with our lists. So if we have a list, 1, 2, 3, we store that in a variable called C. Remember, this is now pointing to a memory location in memory, and 1, 2, 3 is now actually holding that memory location. C is holding that memory location of where this list is stored, but we'll talk more about that as we move further through this. We're going to call the function sum and print the value of sum, and it's adding up the values of this list. So let's give that a try in EarSketch and see what we get. So we can see that we have our list set up, we print out sum, and when we run it, we get 6. We could add in some more numbers here, 4, 5, 6, 78, 60, 56, 34, and hit run, and it will add all those up for us. So that can be useful. Okay, this next one will actually help us understand one of the things we were talking about in the previous lessons. We were talking about the different types of numbers, and Python does this nice thing where it just kind of figures it out for us. So if I have this variable called mylong, and I put this really, really big number, it is too big for an integer. But I don't really get any information from Python telling me that it's going to do something with this and store it as something separate than an integer. But now what I can do is use the type command and tell me what is the type, what is the data type of this variable. So let's go ahead and give something like this a try in Python. So I have my number here called mylong, and I have my number put in there, and I check the type, and guess what? It turns out to be long. If I shorten this, make it just like 898, and now run it, hey look, Python said, hey, that's fine as an int. If I put it as a decimal and run it, Python says that's a float. If I put it as a decimal that is longer than 16 digits, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits, this should be, if I put enough digits, oh, it's still float. Let's keep going. A lot there. That might be too much, but let's see where we're at. Still float. Wow, we got a lot of precision here, more than I thought. Put some numbers over here. See if we can get this to be, get all the way out to a double. Nope, still coming out as a float. Maybe, My precision is too high here, and I can't get it to be a double. Nope, it's still coming out to be a float. Okay, so if I make it big enough, eventually it does come out to be a double. One of the other types that we looked at was a string. So if I run this, and I can see that it's a string. str is the abbreviation for string. Another example that we looked at is I can use the constant true. And we can run this, and we should get that it's a Boolean, and they abbreviate that with BOOL. So if you ever want to know what kind of type something is turning out to be, you can use this type command. The next method that the next function I want to look at is called sorted. And this will take a list, which we've learned about before, and sort it and store a copy of it. So we're going to sort this list, and it will print out a copy of that sorted list. It's not actually changing this list. It's printing out a sorted copy, and we can prove that for us. Let's take a look at this in EarSketch. So I set up my list here, which is just a list of characters. I'm going to print the sorted list, and I'm going to go back and print the original list just to demonstrate to you that it's not changing C. It's copying C into a new list that it is totally sorted and printing that out. So let's take a look. And look, we can see A, B, Q, Z, and we still have our original list of B, Q, A, Z. So it prints out the sorted list, but then it still maintains the original list. C has not changed, which is important to note of what the function is actually doing. The next function that I want to talk about actually takes different kinds of arguments. This is called the range function, and we're going to get a lot of use out of the range function. So it's really important that we pay attention to this. If we do range 5, we will get a list of numbers, 0, 1, 2, 3, 4. So there's 5 numbers there, and it starts at 0 by default. If I do range 3, 8, it will give me a number starting at 3, but then go all the way up to 1 less than 8. So it's not going to give me 8 digits. It's not going to give me 8 numbers here. It's going to go from starting at 3 and going up to 1 less than 8. Much like this went up to 1 less than 5. Range 2, 12, 3 will start at 2. It will give me a value that is less than 12, but it's going to count by 3s. We can also run this backwards and do 20, 5, -5, which will start at 20, and will count down to a value that's less than 5, but not equal to, or excuse me, greater than 5, but not equal to 5, and it'll be subtracting 5 each time. So we can really use range to get a whole bunch of different values. Let's try this in EarSketch, but I'm going to do something interesting with it. So last time we used the sum feature, we had to put it in our own list. This time I'm going to use range to give me my list of numbers and have that add up all the values starting at 0 and going all the way up through 99. So let's give that a try. And look at that. We got 4,950 by adding up all the numbers from 0 to 999. That's pretty useful. We could also count this out. Let's say we want to go from 20 to 100. Let's go to 101. So that way we get all the way up to 100 and add that up. And that's 4,860. Suppose we want to go 20 to 101, but we want to count by 3s. Run that, add it all up, and give us our list, and it sums them all up and gives us 1,593. If we want to verify that it's not changing our list here, and it actually is giving us a list, we could print out C. And look, there's all of our numbers printed out for us, and there's the sum of them. So that could be very useful, especially in some of your Algebra 2 classes when you're calculating sequences and series. This is a series, and this is the sum of that series. Could be very useful. Finally, this is the one that is the most fun, because for the first time, we're going to be able to get information from our user. So let's get our user, whoever's running our program, to write some music with us. So I'm actually using another method as well to go along with input. So input takes a string. And what I'm going to do is I'm going to store the values that the user enters into these 3 variables: track, measure start, and measure end. But the fit media only takes arguments that are integers. So I'm going to use a method called int, which should be familiar. Int is one of our types. And we're going to change the input that's a string to an int. So that way the computer recognizes that we've typed in an integer rather than just a string. See, the computer doesn't know the difference between a 45 that's typed on the keyboard and the letters AB until you tell the computer that 45 is a number. So we have to make sure that we do that with the int command. So let's take a look. If we run this, oops, wrong button. Run this. It's going to ask us first for a track. So I'm going to say track 2. And I'm going to say I want it to start at measure 3. I want it to go to measure 34. And you can see that down here it has written for us our music in track 2, and it has given us 34, up to 34 measures starting at measure 3. So that kind of worked out nicely for us. We're actually letting the user write in music, and every time we run it, the user gets to write in a different piece of music. We can hit play. Quiet. Right, I'm going to stop that because that's going to get annoying. But we can rerun it and get a totally different result from the user. So track 1, first measure. Let's just do up to measure 2, so that should only produce 1 measure of music. And we hit play. And we can see that we get exactly what we expected, 1 measure music. So this is going to be very useful for us for getting input from the person using our program, to help write the song. So that can be kind of fun when you share your scripts with other people. Maybe you have a couple tracks laid down, and then you let them choose what kind of sound that they want to add to it. So of course you can also use this to get just plain text, maybe the person's name, and you want to say, hello Jack, how are you doing? Kind of make it responsive. Absolutely, you can do that. But for our purposes, a lot of times we'll be using the input to mess around with music. So that's all of the methods that I wanted to look at today. Functions that I wanted to look at today. Methods are something else. We'll look at those later. And I wanted to dive into Blackboard so we can see what our assignments are. So here's the notes from today's lesson. You can look at that as a PDF. You have an exit ticket for this lesson that I would like you to work on. And then we also have a practice assignment. And what I would like you to do in the practice assignment is create a script that demonstrates each of the functions that we talked about today and make sure that you print the values on the screen. We don't want to just run the function by itself. We want to catch that result, and you can either catch it in a variable and print it, or you could just catch it into the print statement and print it right away on the screen. Again, you're going to download both the music, because it'd be kind of cool if you use the input feature to make music, as well as the .py file, as well as paste your code into the written submission. So good luck with that, and keep coding. Never stop coding.